Raspbian Linux, now officially known as Raspberry Pi OS, is more than just an operating system. It is the heartbeat of a revolution that transformed computing, education, DIY electronics, and open source culture in ways no one could have predicted. To understand Raspbian is to understand the magic that happens when accessibility meets innovation. It is the system that powers millions of Raspberry Pi devices around the world. From bedrooms to classrooms, from robotics labs to industrial machines, from tiny home automation projects to major creative experiments, this video script takes the viewer on a long, complete journey through Raspbian's origins, design philosophy, ecosystem, performance, features, evolution, and real-world impact. It slowly builds an experience that reveals why Raspbian became such an iconic part of the Linux landscape and why it continues to grow year after year. Imagine beginning the video by zooming out from Earth, diving down through the clouds, sliding across the landscape, and finally landing on a tiny Raspberry Pi board sitting on a desk. The narrator begins by explaining how this palm-sized computer changed everything. Before the Raspberry Pi was introduced, computers were still expensive, often costing hundreds of dollars. They were also large, power-hungry, and out of reach for many people, especially for students or children in developing countries. The Raspberry Pi Foundation set out to change this. They wanted to create a cheap, compact, energy-efficient computer that could teach programming, empower creativity, and give anyone the chance to explore computing. But hardware alone would not accomplish that goal. It needed a software environment that was equally accessible, equally lightweight, equally educational, and equally empowering. That operating system became Raspbian. The narrator continues by telling the story of how Raspbian was created by two developers, Peter Green and Mike Thompson, who optimized Debian for the ARM CPU used in the Raspberry Pi. Debian, one of the oldest and most stable Linux distributions, was already known for reliability, but it was never designed for tiny ARM boards with low memory and limited CPU power. Raspbian was built from scratch to change that. Every package was compiled with RMv6 optimizations so that the Pi could run smoothly. Everything was tuned for speed and efficiency. This foundation became the bedrock of what millions of Pi users rely on today. The video transitions into visuals of the Raspbian desktop environment. Before the Pi 4, when hardware was limited to 512 megabytes or 1 gigabyte of RAM, performance needed to be efficient. The LXDE desktop chosen for Raspbian was lightweight and fast, using minimal system resources while still offering a familiar computing experience. The narrator describes how the desktop looks simple, taskbar clean menu, approachable layout allowing new users to dive in without confusion. Over time, Raspbian evolved into Raspberry Pi OS, and LXDE merged with components of LXQT to form the smoother, modern Pixel desktop. Pixel delivered elegance without sacrificing speed, bringing polished icons, improved theming, and a more refined user experience. Yet it still remained true to the idea that even the simplest hardware deserves a responsive, stable desktop. The script goes deeper into Raspberry Pi OS's built-in educational focus. From the beginning, the Raspberry Pi Foundation wanted to teach kids programming in a fun and approachable way. That is why tools like Scratch Python with Thonny, Sonic Pi, and Minecraft Pi Edition come pre. The narrator explains how Scratch teaches the basics of logic and programming using colorful drag-and-drop blocks, how Thonny makes Python approachable for beginners, letting them learn coding concepts without needing complicated ideas, how Sonic Pi allows kids to create music using code, and how Minecraft Pi Edition gives users a virtual world where they can write Python scripts that modify the environment in real time. These tools turn learning into play, turning programming into creation. Students who never wrote code before suddenly become capable of building interactive stories, games, music systems, and automation scripts, all powered by Raspbian. Then the narration shifts to the terminal, the heart of any Linux system. Raspbian, like Debian, offers a powerful command line that gives users full control over the system. The script builds a slow, cinematic moment as the narrator speaks about how typing commands into a Pi feels like unlocking a deeper level of computing. Whether a user is controlling GPIO pins, installing software, or configuring system services, everything is flexible and open. This accessibility is why Raspbian became the preferred environment for electronic hobbyists, tinkerers, and DIY makers. It acts as a bridge between software and hardware, between logic and creativity. The video now transitions into one of the most iconic features of the Raspberry Pi ecosystem, the GPIO pins. Raspbian Linux integrates seamlessly with the Pi's hardware, allowing users to control LEDs, sensors, motors, cameras, displays, and more. The narrator explains how Raspbian provides simple Python libraries like RPI, .GPIO, and JPO0 that allow beginners to control hardware with just a few lines of code. The script shows close-ups of LEDs, blinking, motors spinning, sensors detecting movement, and robots coming to life, all controlled by Raspbian. This section emphasizes how Raspbian turned the Raspberry Pi into not just a computer, but a gateway to electronics, robotics, automation, and engineering projects. Next, the script focuses on the package ecosystem. Raspbian uses the APT package manager inherited from Debian, giving users access to tens of thousands of software packages, everything from office suites to programming tools, from multimedia players to servers, from emulators to networking utilities, is just a command away. The narrator describes how the Raspberry Pi Foundation maintains additional repositories to ensure compatibility and stability. They test packages to ensure they run well on limited hardware and provide updates that balance new features with dependable performance. With the foundation of software explained, the video moves to a deeper technical perspective. How Raspbian handles performance optimization. Unlike conventional PCs, the Raspberry Pi runs on ARM processors with limited RAM. This requires highly efficient resource management. The narrator explains how Raspbian uses ZRAM to compress data and memory for better multitasking, how swap is tuned to avoid unnecessary wear on SD cards, how boot times are optimized, and how services are minimized to reduce overhead. The video visually demonstrates this by showing a Pi handling, web browsing, document editing, and coding all at once without feeling sluggish. In the next scene, the narrator introduces the idea of the Raspberry Pi as a server. Although small and portable, the Pi running Raspbian can become a home server, a media server, a DNS server, an ad blocker, a file server, or even a cloud environment. The script explains how Raspbian supports tools like Pi-hole Home Assistant, Nextcloud, Plex, and OpenMedia. A slow montage shows a Pi sitting quietly on a desk, running 24/7, consuming almost no electricity but powering an entire network. This section emphasizes how Raspbian turns the Pi into a tiny but mighty powerhouse for home automation and networking projects. The script transitions into discussing the Raspberry Pi OS Lite version, the command line only edition. This lightweight variant is ideal for servers, headless systems, and embedded projects. The narrator describes how it boots extremely quickly, uses almost no RAM, and provides a perfect environment for scripting, automation, IoT devices, and robotics. The absence of a desktop is a strength, allowing the Pi to operate efficiently for long-term projects. Then the story shifts to Raspbian's role in education worldwide. Classrooms in over 100 countries use Raspberry Pi computers running Raspbian as the foundation for teaching computing. The narrator shows images of classrooms, children engaged in coding activities, teachers explaining electronics, and Pi devices powering science labs. Raspberry Pi OS includes tools like Genie, BlueJMU, Editor, and Wolfram Mathematica, making it suitable not just for beginners, but for advanced learning. The script highlights how students can build projects, write code, and experiment with electronics, all using a system that costs a fraction of traditional computers. The narrative now becomes more reflective, explaining how the ease of installation makes Raspbian approachable for everyone. Tools like Raspberry Pi Imager simplify the entire process of writing the OS to an SD card. The narrator walks through how users choose their OS, write it to their SD card, insert it into the Pi, and boot. Within minutes, a full Linux environment is ready. This simplicity is vital for education and for new users taking their first steps into Linux. The video transitions to the evolution of Raspbian into Raspberry Pi OS. Over time, the system has undergone significant changes, including support for new hardware like the Pi 4 and Pi 02W. The narrator explains how updates allowed Raspbian to evolve from 32-bit ARM6 to supporting newer ARM CPUs, offering 64-bit versions and improving performance dramatically. Pixel's desktop interface matured, the kernel upgraded, and compatibility broadened. Yet, through all these changes, the operating system kept its spirit: lightweight, flexible, stable, and educational. The script moves into discussing the vibrant community surrounding Raspbian. The Raspberry Pi ecosystem thrives because of its global network of developers, makers, teachers, hobbyists, and enthusiasts. Online forums, YouTube channels, GitHub repositories, and community workshops all share Raspbian-based projects. The narrator showcases DIY projects from retro gaming consoles to smart meters, from home servers to weather stations, from security cameras to robots, each powered by Raspbian Linux. This part of the script highlights how the OS brings people together, inspiring collaboration and innovation. As the video approaches the final third, the narrator dives deeper into the security features of Raspberry Pi OS. The system includes frequent updates, secure boot options, a default user management system, firewall tools, and hardened configurations. While it is not a security-focused distribution, it offers reliable protection for educational and home uses. The script also explains how the Pi's lightweight footprint makes it ideal for experimentation, without fear if something breaks. Users can simply reflash the SD card and start again. This encourages learning through trial and error, which is at the core of the Raspberry Pi philosophy. The script then explores advanced uses of Raspbian compiling software, building kernels, running Kubernetes clusters, hosting websites, or experimenting with AI models. The narrator describes how Raspberry Pi OS increasingly supports modern technologies thanks to its evolving kernel and libraries. Pi running Raspbian can power complex experimentation at a fraction of the cost of traditional servers or development machines. The video transitions into a section describing how Raspbian remains friendly even for complete beginners. The welcome wizard helps users set up locale, Wi-Fi, password, and screen resolution. The Sulfur configuration tool RaspiConfig provides simple ways to enable SSH, expand the file system, configure interfaces, or overclock the CPU. The narrator explains how even tasks like connecting to networks, installing updates, or adjusting the system are made simple through beginner-friendly menus. In the final stretch, the script reflects on the cultural impact of Raspbian Linux. It didn't just support the Raspberry Pi. It fueled a global movement. In countries where computers were too expensive, the Pi run in Raspbian became the first computer many students ever used. In maker communities, it became the brain for inventions. In education, it became the symbol of creative learning. In technology, it showed that powerful computing does not need to be expensive or closed source. Raspbian gave millions of people around the world access to Linux, programming, and engineering in ways no other OS had done before. The script ends with the camera pulling back from a Raspberry Pi on a desk, rising upward through the roof, into the night sky, and back into space. The narrator concludes by saying that Raspbian Linux is not just an operating system, it is a movement, a platform for creation, a tool for learning, and a gateway to innovation. It embodies the idea that computing should be accessible to everyone through classrooms, workshops, hobbyists, and dreamers. Raspbian continues to shape the future, one tiny Raspberry Pi at a time.